Hello world, Paul Whittakin back. Peace and happiness to all. And I'm going to continue to cover this universal law of numbers that I talk about, which is a 369 code. And the first thing I'll mention is, we don't even see a 3, 6, or, well, we see a lot of 9s for sure, because 9 is the queen bee here, but there's no 3, 6s, or 9s in there, or 3s or 6s in there, but I'm going to help bring them out of the shadows a little bit today, and that you might find that interesting. Another thing I want to quickly bring up is we have the code 248751, 248751, 248751. We also have the 417 or the 741. We have the 181 and the 818s. So these are codes embedded within the code, and they all play a role. And we'll kind of begin to understand that. And one thing I want to also point out is these codes, they exist. You can see them going crosswise as well. Just as an example, 248751, 248751. We've got the 417s in there, 471s, 471, 471. We have the 818 inside going this way too, 181, 818, and so on and so forth. So everything, everything that's in there, well, there's a lot of things that are hidden in there, but if we do some basic arithmetic, they will come out and they will show their face. So we're going to do a little bit of that today. Now, this 369, I've mentioned that is the way that numbers triple. And what I mean by that is 1 tripled is 3. So 2 tripled is 6, 3 tripled is 9, 3, 6, 9. 4 tripled is 12, 3, 5 tripled is 15, 6, and 6 tripled is 18, 9. 7 tripled is 21, 3, 8 tripled is 24, 6, and 9 tripled is 27, 2 and 7 is 9. Now it continues from there, of course, because 10 tripled is 30, but we don't talk about tens. We don't talk in terms of 10s and 11s or anything like that, but we'll just kind of do it. 10 tripled is 30, but 10 is a 1, which is a 3. It's the same as 3 tripled. 11 tripled is 33, 11 is 2, 2 tripled is 6, so 33 is going to be a 6, it's 3, and 3 is a 6. 12 tripled is 36, which is a 3, and 3 and 6 is 9. 13 tripled is 39, 3 and 9 is 9. 14 tripled is 42, 4 and 2 is 6. 15 tripled is 45, 4 and 5 is 9. So 369 continues on forever in that sequence from 1 to infinity. Now if we go across the second time you triple it, it always comes to 9. For instance, 1 tripled is 3, but triple 3, it's a 9. 6 tripled is 18, but triple 18, 54, that's a 9. Triple 3, it's 9, but triple 9 is 27, that's a 9. So all numbers, they go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, even though we don't talk that language. 369, 369, 369, but the second time you triple it, it goes to 9, and it keeps on staying at 9 into infinity. So 1, 2, and 3 add up to 1, 2 is 3, and 3, that's a 6. That's not a coincidence. 4, 5, and 6 is 9, and 6 is 15, which is 6. That's not a coincidence. 7, 8, and 9, 15 and 9 is 24, that's 6. That's not a coincidence. 1, 2, 3, 4, 5, 6, 7, 8, 9 is 45, which is 9. That's not a coincidence. 1, 2, 3, 4, 5, 6 is 21, which is 3. It's not a coincidence, okay? So, because of that, it brings symmetry, simplicity, maybe synchronicity, okay? So what we're going to do is we're going to get started. I'm going to show you basically, why don't I do one thing here, because I think this will basically provide some insight into the power of the code. Now, what happens in the code, as you may all know already, is when we square a number, we get, it simplifies to that number. So we squared 1 is 1, 2 is 4, 3 is 9, 4 is 16. Add, do the arithmetic. 5 is 25, do the arithmetic. 6 is 36, 7 49, 8 64, 9 is 81. 10 is 100, but 10 is a 1 is 1. 11, 121, but it's a 2, but 121, do the arithmetic, it's 4. 12 is 3, squared is 144. 13 is 4, 13 squared is 169. 1 and 6 is 7, and 9 is 16, which is a 7. 17 squared is 289, right? 2 and 8 is 10 and 9. No, I'm doing something wrong. You see, so now I know. So I was up to, 10, 11, 12, 13 squared. 13 times 13 is 169. We'll get that. 14 squared is 196. 1 and 9 and 6 is 16. 15 squared is 225. 2, 2 and 5. 16 squared is, what was I up to? Well, 16 squared, right, is 256. 2, 5, and 6. Yes. 289. Yes. 324. 3 and 2 and 4. Yeah. 361. Yes. 400. So 400 is a 4. So we got all the way up to 4. Where did I do that? 9 was 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Okay. So that's how that works. Because 20 squared is 400. 20 squared is 400. 20 is a 2, comes to a 4. Okay, so sometimes I get a little bit mixed up, and I hope you can bear with me, but that's the beauty of this thing. It's going to solve all of the problems for me. And every time I start getting mixed up, it will set me straight. So another thing I want to point out here today is the power of this thing. Because it's easy to overlook, and I make exaggerated claims, some might assume, but what it does is it simplifies the largest and the smallest, tiniest fraction of a number, and it brings it back into simplicity. So what we're going to do is you just take a calculator, or you can do it on a piece of paper, and I'm going to show you that this thing is more powerful than your calculator. It's a supercomputer, okay? So let's just do, take 1, 2, and 3, which I mentioned before is a 6. And if we square 123, we're going to get a number of 15,129. So 1 and 5 is 6, and 1 is 7, and 2 is 9, and 9 is 18, so that's going to be a 9. So a 6 number, like 1, 2, 3, is going to yield a 9 when we square it. Now that's fine, you can verify that on your calculator if you use calculators for things like that. Now we're going to run into where the problem is with calculators. Now I have a calculator right here, and we'll take a bigger number. We'll take 1, 2, 3, 4, 5, 6. And 1, 2, 3, again, 6, 10, 15, 6 is 21, it's a 3, okay? So if 1, 2, 3, 4, 5, 6, the number 123,456 is a 3. So if we were to square that, it would reduce to 9. But here on my calculator, 1, 2, 3, 4, 5, 6, and I'm going to square it. Okay, so we have, I have 1.524138 to the 10th power. So let's add that up. 1 and 5 is 6, and 2 is 8, and 4 is 12, and 1 is 13, and 3 is 14, and 8 is 22. 22 is a 4. That doesn't come out right. Well, who's wrong here? The calculator, because the calculator has to make some sort of approximation to come up with that big number. But it's wrong because it's not exact. It stops at the wrong it stops to round off. With this computer, supercomputer, we can calculate much larger numbers to reduce them to their power, which has meaning too, because we can take a number, let's say 123,456,789, and get the correct answer, how it's reduced. So 1, 2, 3, 4, 5, 6, 7, 8, 9, that big number, it reduces to 45. 45 is a 9. So when we square this number, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to become a 9. If we take it to the third power, it'll be a 9 too. If we take it to the 7th power, it'll be a 9. To the 8th power, to the 9th, 10th, 11th, 12th, 13th, 14, 15, 16, 17, 18, 19, on to a billion. And it doesn't stop there. 10 billion. No, it doesn't stop there. It never stops. That's what the power of this is. So what we have here is quite a powerful tool for calculating if reducing numbers means anything. Does reducing numbers mean anything? Well, to the universe it does, obviously, because that's how I came up with this code. And all of these numbers, the way they're arranged, they are really telling a very interesting story. So what we'll do is I will just go back to where I left off yesterday, and I will just plug this thing up here. No, that's not the one I was doing yesterday. Maybe I don't have it. I hope I have it. I believe this is the last one I had up here yesterday. Put that up there. Okay. So what I suggest people do in order to understand numbers is do arithmetic by applying the code with the codes within